Hello and welcome. We have arrived to the end of the Unit 1, which is Introduction to Vectors, and we're preparing for the unit test. And today in class, you asked lots of questions about the review, and I kind of made a promise to make some video recordings for some of the questions we couldn't take up together, so here I am. I'm going to start off with question number 3, and that is lesson U1A5. Here on top, you can see the lesson number. So in this question, we are trying to find out or to analyze each and every expression and see which ones make sense and which ones don't. As you can see, we have a combination of dot and cross product, and in some cases, we have addition of vectors. So before we get started, I want to clarify with you some very important key concepts that will help us better understand the solutions. Remember that so far we have looked at the following. So we say the dot product, which is also known as the scalar product of two vectors, can only happen between two vectors. And we're going to make this dot very pronounced in here to show that we are talking about the dot product in here, which is a form of vector multiplication, so vector to vector. The next product that we looked at was the cross product. And again, cross product, it's another form of vector multiplication, which we denote by A cross B. And again, it's an operation that can only exist between two vectors. And I'm going to talk about the last one, which is very important and gets very often confused. The scalar multiplication. So it has the word multiplication in it. And we also know that dot product is also known as a scalar product. And that's where it gets a bit confusing. When we say the scalar product, we mean the multiplication of two vectors by this operation here, or the dot product. Now, when we say scalar multiplication, on the other hand, even though they're both sort of products, and both have the word scalar in it, there's different types of multiplications. In scalar multiplication, we are allowed to multiply a scalar or a number by a vector. So this is a multiplication of a number with a vector. So again, remember scalar product, a vector with a vector. Scalar multiplication, a number with a vector. And cross product is the product between two vectors. Now we remember that scalar product, A dot B, is a scalar or a number. So the answer will be a number. Now cross product, A cross B, that would be a vector. And scalar multiplication, which is a number times a vector, that must be a vector as well. So let's get started with question A. In question A, we have A dot B cross C. So very simple, very straightforward. So what we see in here is the dot product of some vector A with B cross C. So B cross C, if you look at it, that's a cross product, so that will produce a vector. Now A is already a vector. So now we're thinking, can we dot product a vector with a vector? And we're going to very happily say, oh yes, we can do that. And we will get, as an answer, we'll get a scalar, so a number. So moving on to the next question, which is A dot B, and this will cross C. So that would be question B here, okay? So let's take a look at this. So that means that we have to focus first on A dot B. A dot B is the dot product of two vectors. So this will give a scalar. And this scalar must cross this vector in here, the vector C. Now remember that a scalar cannot cross a vector. Remember, only two vectors can cross each other, not a vector and a number. So for this, we're going to say this is not possible. Moving on to question C. In question C, we have A cross B dot C plus D. So again, let's think about this. So A cross B, think what we get from A cross B. That's cross product. We get a vector. And C plus D is the sum of two vectors. that will give another vector. So what we have in here is vector dot vector. Can we dot product two vectors? Of course we can. And we're going to say that the answer will be a scalar. So I hope that you kind of get the idea now. We're going to move on to question D. So question D is A dot B multiplying C cross D. So remember that in this case, what you see in here between the two brackets is a simple multiplication. So no dot product or no cross product. So just pure multiplication. So in this case, in the first brackets, we're going to get A dot B, which is a scalar. Now C cross D will be a vector. So remember that the multiplication here is like a simple multiplication, like a multiple of something. So it's not a dot product. That's why you don't see the dot in between. So we are thinking, can we multiply a scalar by a vector? And we're going to say, well, wait a second, isn't it this one, right? So a scalar multiplying a vector. So we're going to say, yes, a scalar and a vector can multiply to give a vector. Now moving on to question E. For question E, we have A cross B. Sorry, I'm writing over. And then multiplying or crossing C cross D. So let's take a look at this. So A cross B, that will give another vector. I have an idea. Here we go. So A cross B is a vector. C cross D, that's another vector. So we are crossing a vector with a vector. Is that possible? So we're going to say definitely yes. So, and the answer will be another vector. Next question, we have A cross B plus C. So we have to pay a little bit of attention here to each and every part of the expression. So in this case, we have to cross A and B first. Let's bring it here. So this would be question F. So let's write that down. So A cross B will be a vector. And then B plus, and then vector C itself is another vector. So we're trying to add a vector to a vector. Is that possible? So we're going to say yes. And the answer will be another vector. I hope this made sense. And I will see you very soon in the next examples. Bye for now. Thanks for watching.